Happy Tuesday.
Hi, Eric. Welcome to Rubber Duck Engineering.
Yes.
Special
Nice
holiday edition.
Yeah, it's the daytime.
The daytime? Does the world even
Daytime.
exist during the day? I thought it only existed at night.
I don't know. Normally I'm at work during the day, so I'm not doing Rubber Duck Engineering-y things. But anyways, nice to see you, Adam. Happy holidays.
Yeah, happy holidays to you.
So today, what'd you say?
Oh, go for it. You should do a 30-second intro.
Well, today we're going to do some drawing with a canvas, maybe draw a Christmas tree or other holiday apparel. We'll see how far we get. And otherwise, just kind of hanging out. You know, last episode of the year. Ren work continues, but we didn't plan to do that today on camera. So
you were talking something more festive and sort of fun.
Yeah, and this I get to pull out the hat and all. So, anything you want to say to folks before we jump in?
No, let's go to the code machine.
To the code machine.
I wonder how many of our episodes start out with just the Flutter template. This hello Flutter demo page with the clicky button that increments the number.
You mean just episodes beyond ours or ours?
No, even just this show. Oh god, I shudder to think how many times this template has been instantiated. But even just on our show. Oh,
okay. I suspect we have those stats somewhere. A lot is the answer. So because we have to share the whole screen, I don't actually see viewer comments and stuff today, and I can't actually see you. I just see Code Machine.
Okay, I can stay on top of the comments.
We're doing this.
We're broadcasting at a strange time, so I don't know how many regulars will be here, but that's fine.
So we were gonna see about drawing some things. I suspect there's actually emoji.
Emojis? No, I thought we should just make a canvas and try to do geometry and trigonometry and bust out a bunch of math.
Yeah, I think it'd be fun to work out the math of how to draw a tree.
Okay.
We're gonna treat this like logo.
I think we should delete this all of this. Just
boom. Whoa, we're gonna start. We're gonna start from scratch.
Well, we're gonna have my app. You can't not have my app.
Oh, okay.
Oh, stateless widget.
Stateless widget.
Tree widget. Awesome.
That's a nice long name. Sure. Don't need a title.
Okay. Custom paint. Size box. Expand.
Okay.
Custom paint. Painter.
There's a holiday village. I don't know what makes that holiday.
Holiday village icon?
I just was seeing what icon. I don't see a tree icon.
Okay, I'm just gonna try to fill the canvas with a color here so we can see what's going on here.
One of the most popular web pages on our docs is the page that lists all the icons, and I understand why. You kind of need
always look at it, right? What is?
Well, it's something you want a visual search with. All right, what do we got going here? We got a tree painter. We put it in the size box to make it big. We haven't saved yet, which is why it hasn't updated.
Fill the whole thing with green. I figure that's the beginning part of any
green square. I don't think this is not going to make you happy. You need to be returned.
Did it, team?
Why is it not updating?
Is there an error?
Oh, you know what? I bet I ran this from the command line. In fact, I'm almost certain I did. Because I was just trying to get things building in the Easy Bake Oven before everybody showed up, and it all went wrong. Start debugging.
Sure.
I think it's gonna. My goodness, my Chrome's going crazy. It should have it all cached.
So Eric, how was your week?
How's my week? It's been weird getting used to like not having stuff to do. Been doing catching up with things around the house, seeing some family, baking some cookies, helping some neighbors distributing cookies. Yeah.
We did a major house cleaning. Like we got the living room, all the toys off the living room, and everything like in ship shape.
Wow, your green is very festively hollow.
No, I just picked one of the material design shades.
So I think that this should be working now. Yeah, okay, it is.
Good. Okay, good.
Ah.
All right. Now the like trigonometry begins.
Well, we should be able to draw a star.
Oh, okay.
So like, void draw a star. Paint. Canvas. Size.
All right, so I can try to draw the like tree, the stump of the tree while you work on the star.
Yeah, like some of the trees should just be black, right?
Yeah, I'm just thinking erect. Okay, you want to work on the star?
Yeah, I'm just trying to think how you draw a star. It's like you inscribe a circle with 5 points.
Yeah, that sounds good.
I mean, that's how you would like do it as a kid, right?
Yeah, I think that's good. You probably want the star to come up to the top point, right? So if you make that your 0, and then you do all the angles like 2 pi divided by 5 or whatever, and then use sine and cosine and put all the.
Is it going to fill correctly? We'll see. Yeah.
I don't know.
Angle is 2 pi divided by 5, and then you do a 1 to 3 to 3, 4, 2, 1, 3, 2, 3, 2, no, 1, 3, 4, 4, 2.
You need to do all of them? Like you need to.
I don't know. I'm just like I'm totally doing this on the fly here, man. 0, 1, 2, 3, 4. Yeah, so 0.
Let's take an offset too.
4.
Let's just take a rect. Oh, maybe we need
1,
like a.
1 to 3 to 0. That should be draw a star pattern.
Double radius.
Sure, you can do it with radius. You can also inscribe the circle in the. But yeah, this works.
No, there are 5 of them, right? So. Oh, we just want the sequence.
Well, this is the.
We need a way of computing each point, right? So. Maybe we want like a list that's gonna have all the points.
Sure. And then the points are the inscription of a circle.
This is going to be.
Yeah, we really are doing our trigonometry today.
Oh yeah, that's all fun of it. So like use a bunch of math. Okay, so the x is cosine, right? Cosine of angle step times I. This is going to be the y is going to be sine.
Yeah, this looks right.
And then we need to add this to the center. The centers.
Yeah.
Center dot dx.
Yeah.
Y, and then we need to use the radius to multiply times our metric function. Okay.
Yeah.
I was wrong here.
It should
what
be
is it on red?
Problems. 2 positional arguments expected. This is probably generate. You have to give it, 5.
Oh, okay, that's legit.
Okay. This is probably math dot.
Oh yeah, math dot. Yeah, that's legit. Lowercase m, I think.
Okay, so we have our points. And we just
we need to start. We want to start with the top point at straight up and down. So that means we want to start. We don't want to start at 0, which would be having the top point at horizontal. So we want to go by pi over 2, I think.
Yeah.
Plus pi over 2.
Half pi. Yep. I would just pull this out into a constant, but yeah.
Okay, go for it.
Pi over 2.
Okay, it's legit.
Seems legit. All right, and so now we're just going to do literally write these out. We're going to do canvas.
We need to paint. Yeah, we need to paint, right? So paint equals maybe the color should pass in the paint.
Sure. Isn't there like a draw lines?
Oh, yeah, maybe. You can do a path. You make a path. Put
You
the
can make
lines
it a
in.
path.
Yeah.
Okay. Let's see if I can figure out how to make a path.
Maybe this whole thing should just return the path.
Whoa. Sure.
And I actually think the way this works is you're supposed to pass in the path. Path, add star, right?
Add. Whoa, what's add polygon?
Points. So that's
Yeah,
going to be like
I mean,
a convex polygon, right?
Yeah. The problem is we aren't calculating in this the inner points, the intersection points, which we could do.
Oh, well, let's just try it the naive way and just draw the lines, and then we'll try to do filler.
So this should just be add path. Oh no. I want where's it like move to? Yeah, move to. Oh, doesn't split these out? That's lame. I'm gonna name this P. What was my sanity then? P 0 x. Oh, these are dx and dy? Sure. I'm so tempted to just like make a make some helper functions here.
Oh, that just draws the.
But just where you can explain this in your little DSL, right?
Mm-hmm.
I'm resisting. Be strong.
Well, don't have to resist. You can make a beautiful like star painting function.
That's okay.
It's a work of art. The whole thing.
And now, path dot. I mean, this is the close, so we shouldn't have to close. Although I expect it automatically closes. Let me just return path.
Oh, you don't have to return path. We're mutating the caller passed in the path, and we're mutating it.
Why is that?
That's just sort of a normal way of dealing with paths, right? Just like add polygon, right? This is add star.
Right.
So nothing happened. Just kind of sad.
Well, we have a compile error. Shade 600.
Oh, I wanted hello. Oh my gosh! It's a giant star.
You did it.
Oh, you know what? I gave the wrong side. This wasn't the radius.
I'm really impressed that we passed 6th grade trigonometry here.
I love it. It's a star.
Like I know that it's a perfect star, but like it looks bigger at the top than the bottom. Like I want its little arms to be smaller.
Why are you so surprised that this worked, Eric?
Why am I so surprised? What?
You seem very surprised that it worked.
Well, I feel surprised when anything works.
I am surprised I never write a bunch of like trigonometric like canvas functions when it like does anything close to reasonable.
Well, I mean, we've talked about this before that like, there's so many tangents I could go on, but like we talked about this before that like so much of software engineering is doing all these things that you just rarely do. You just like dabble in a little bit. So I'm a little surprised that anything worked. But great, we have a star. It maybe, okay, I'm gonna maybe move it up here a little bit. What do we got? Add star, center, offset 0. Yeah. I want this. I really want this to be.
Okay, let's make this a little bit smaller. Just for the sake of our sanity's sake. And let's move it up. 5 like it.
I'm
Because
gonna make,
it's supposed to go on the top of the tree, right?
what's your offset unit?
I don't know. I was just trying to get some scale size that was like something to do with the size of the canvas.
Yeah, I was thinking about making a little helper to like, because we kind of want to like just be in unit size. We could just be drawing in a 200 by 100 kind of thing, or 100 wide by 200 tall, and then we could just scale.
Well, that was the idea behind unit. Is just unit can be that number for us, and then it'll scale with the size of the canvas. Is there a compiler? What did I do wrong here?
Cannot be assigned to parameter type offset. What are you doing here? Oh, does offset not have a?
Oh, it's the other way around. Sorry. Yeah, this is a funny thing in Dart where like the operators take their dispatch from their left side.
Mm-hmm.
So it really matters. I think that's too high. Okay, so that's a good place for the star.
The consonants are really aggressive.
Oh, it didn't like final? Final was not legit?
It was like, well, I see that you could even use const here, so do it.
Okay, great.
I mean, it makes sense. You're making the compiler do it instead of like at runtime, but still. All right, let's draw a tree.
Draw a tree.
So I was thinking,
it's a polygon, right?
What'd you say?
I think just like a beginner tree is like a triangle, right? Do we use draw polygon?
Sure.
What were you saying?
Yeah. Well, I was thinking about this after you mentioned this, and I was going to get my tea and stuff. That it's interesting to think about a tree in 3D projected into 2D.
Whoa.
That it's like a spiral that gets smaller. So you could imagine it as a spiral. So as you're going around a circle, and you have a cone that's getting, anyways, we'll get there.
Yeah. Oh, this is true. So what is the type for points? I don't have that kind of autocomplete for it.
List offset.
List of offset. Okay.
So you should just be able to.
Can I make a list like this?
Yeah.
Okay. I think
I share your doubt. since I write more Rust at the moment than I do Dart.
So the top of the tree is there.
Okay.
Right?
Yeah.
Okay. So the first thing I want is top of tree.
Mm-hmm.
And then maybe top of tree plus offset in X, maybe unit, and then in Y, maybe unit times 4. And then the same thing, but minus X. Sorry. Minus unit. And close is true.
Sorry, I started trying to draw the stump, and I ignored you.
Okay.
Add polygon, top of tree plus offset.
Expected a semicolon. It's mad somewhere.
This got pulled out.
Oh, I see.
Funky.
Okay. We never draw it. Draw
Never
path. Draw it, and we gotta give it a color, like a darker shade of green, maybe.
Mm-hmm.
Shade 600. We drew the star.
Yeah.
Okay.
Copy pasta. What's
yeah.
going on here? Top of tree.
I never know how add polygon works. So
why? I don't you want this to be minus? Like, where's the center? Where is 0, 0?
Why don't we try something very, very simple? Like, I think this was a little ambitious. Let's just start out with like 50 offset, like 50-50. Let's see how this works, right?
Mm-hmm.
I don't know, 150, 150, and
Negative 50, negative 50 or something. Sure. Always good. Sure.
Okay, so we succeed in drawing a.
All right, so 50-50 is here.
Okay, so let's try to make the first point go to the top of the tree. That's not legit.
So where does it think the top of
Maybe
the tree?
this needs to be negative here. Maybe this is.
Something's still funky.
Oh, maybe size dot center. Maybe this is the top of the tree. This whole thing here is top of the tree, right? Because we want
What size dot center? Oh, that's like this thing relative to the top of the tree, or relative to the center of this.
this is like
Not what's it called? Local top tree can't be referenced before it's declared.
oh, okay, that's legit.
Yeah. Okay. Yep.
Seeing all of this.
All of this. Okay.
That's good.
Definitely better.
So now maybe we'll try these. Maybe this is these are now more legit. Our Y's are backwards. Who knows which way is up?
Okay.
All right, we're getting there. I think maybe 5 instead of 4.
All right. We still need to break this out.
I feel like the star needs to be drawn on top of the tree.
Correct.
Otherwise, it's well.
Well, really, this needs to be like this needs to go into the tree.
Yeah, we did the same thing, like add tree, like we had add star.
But that assumes that it's a. That assumes that the tree is a path. I don't think.
Oh, what would a tree be besides a path? A path is a very general concept.
Well, I mean, if you want to do raster, but okay, that's fine. We can always refract it from here. This is add tree.
Right. Height and half width, maybe.
Okay. This is here. Find tree path. That's just path. Okay. 4
Right,
possible.
and then, height we want it to be unit times 5. We want it to be wider.
Okay.
It should be taller. We need a taller tree. Need taller? Okay, that looks good.
Sure. All right. So now we need a stump too.
Right.
So this is going to be canvas dot draw rect. This is going to be final stump rect dot.
So we need bottom of tree, right? Bottom of tree is top of tree. Offset X and Y is height of tree. And the height of tree is this. I found when you're writing these functions, you just got to name everything a sensible name. Otherwise, you will never figure out what anything is.
Are you actually using bottom of tree?
No, I figured you would want to use it to make your rect as like a starting point, because it's going to be like in the middle at the bottom of the tree, which will help you figure out where to put your rect.
Well, but your tree path is gonna want to be using this. Oh, I see. It does inhibit from the height of tree. Okay, fine.
Right.
All right, so this is going to be, you're going to want stump width or something like that.
Or stump half width.
Sure. This is going to be unit. No idea. This is going to be bottom of tree minus only X.
Because we have all these fancy tools for making recs.
Did I pick the wrong one?
Yeah, you do like size dot top left, top center, yeah, bottom of tree. You just got to create your size, right? So your size is going to be, so let's just do actually stump width equals unit times 2. Stump, I don't know what your height to be.
Sure, we don't know yet, but that's fine. We can give you separately.
I think that's what this top center thing does. The offset to the center. No, that's not what top center does.
What does top center do?
No, it makes an offset. It doesn't make a rect.
Okay. You want it to like center on or something?
You could definitely make a rect from a like a point and a radius.
Center top edge, the offset to the tops. Oh, I see.
Yeah, from. Let's start with rect from center. Because the center is going to be bottom of the tree plus height over 2. And then your width is going to be stump width, and your height is going to be stump height. Got it.
You could just do. Okay, what did you do here? Rect from center, bottom tree. Okay. Okay, that seems reasonable. What is the stump height? Divided by 2. What is it? Double cannot be assigned. This is probably offset.
Yeah, offset. 0.
Whoa!
It's too big though.
Yep.
Really too big.
Here we go.
Okay.
We have a tree. I think so. Where I was going before was so sort of thinking about tinsel, but also like think about tinsel you could do in the way I was thinking of, in that it's you're like going around a circle.
Well, with the lights, like the lights could wrap around the tree.
The lights.
Yeah. Okay. Should we try that?
Yeah, I'm just trying to think. Like, what are they? Are we drawing arcs between points? Are we drawing?
Yeah, I think arcs would be nice. They give it like a sort of 3D kind of quality. Like, it's just going to be a lot of trigonometry to figure out where to put the arcs. But
no, I actually don't think so. Okay, I have a half thought through thought, but I think you can probably follow. So imagine you are in 3D space. You're starting at the stump and you're going up.
Okay. All right.
Okay. And now you're going around the outside of a cylinder.
Uh-huh.
And so that's just, following the cosine sine curve, right?
Okay.
And now you can change the radius
Yep.
as you're going up.
Uh-huh.
And you can also change the speed. And you also could pick some point on the curve to start and stop drawing.
Okay.
So like you could so like only draw from when, sine is negative pi. I have no idea what this person is.
I'm sorry, I don't understand what this comment means.
That may just be spam.
Oh. Okay.
We get a lot of
It's
spam
text,
comments.
so text sounded like it.
Normally they're after the show. And they're normally the links that you don't want to click on.
All right. Well, normally Eric manages the comments, so this is sorry
Well,
for me.
YouTube does it for me, but I do still get the emails before their little comment thing kicks in. Anyways, so
yeah, I'm totally in for this. I think we should try it. I see exactly what you're saying, right? We just have to get the radius correct.
okay. I'm just trying to think. So I think what you're really looking for is you're looking for those points. And then what is the arcs that you're drawing between them?
Right. So I think we should just try to draw like a horizontal line just to start with.
Okay.
From the left side of the tree to the right side of the tree at some arbitrary point up the tree.
What is this stump rect? Is this
that was our previous attempt to create the rect. Yeah. So, but I think you're right that we should reason starting from the bottom of tree and work upwards.
Yeah, you can probably do it either way. You just run the math. Yeah. Okay.
Okay. So let's try that. So let's just try to draw a line. Okay. But let's take a paint dot color of, let's say, white.
You know me, I have to write out the comments. So starting from bottom left of tree, draw from starting point to next intersection when cosine x equals 1. Where x equals 8 on the cent tree. And then what is the arc curve? Like I think about this in like you're spitting out pixels, but that's not what you actually want. You want to figure out what the
Well, we could, because we just put little dots for each light, right? Like we don't have to do an arc. We want to basically.
Whoa!
Yeah. Oh, I thought that's where you're going with the whole thing. This is why I like working with Eric, is because Eric and I misunderstand each other, but in a way that ends up being productive.
No, I love it. Okay, let's do lights.
Yeah.
Okay. Oh, this is going to be amazing.
Okay, so we want draw a point instead of draw a line, right?
Yeah, or draw a circle or something like that. Or
we'll draw points. We can draw lots of points.
Why don't we run our for loop and?
Well, let's try to draw 1 point first and see, and then we can start making a lot of them.
So this is like while x is less than height.
Point mode. What is point mode?
Height of tree. Height equals 9x. No, this is only going in this direction, right? Cosine x point is equal to offset cosine x. This is y. 4y. All right, I'm off my own little world, aren't I?
If you want to verbalize a little bit more what you're thinking.
I'm still trying to like write out the thing. So this is if this is like I see. This is going to be.
I'm trying to figure out how to actually draw points here.
Mm. So this is
Okay, stroke cap to round. Okay, I succeeded in drawing 1 point,
yay!
which is not nothing. And if you can, all of your exciting math and trigonometry, you can figure out where you want the points. You can have beautiful points.
Yeah. So okay. So I was trying to think through what I was trying to describe earlier. So imagine that you're actually dragging the thing up around the tree, right?
Yep.
And so you're progressing across the Y from the bottom of the tree. You can't see my hands, but I'm pointing at. You're progressing from the bottom of the tree. Oh, but you can't see my mouse. So you're progressing from the bottom of the tree.
Yep. You're moving upwards.
And you're moving upwards. And as you're moving up in the Y direction, you have cosine, right? Because your Y is actually your T or whatever. If you're thinking about this as a cosine curve or whatever.
Yep.
You're running your cosine to like go around.
Yep.
The tree.
And you just want to stop drawing when you're behind. It's like a hidden surface removal.
Yeah. You could stop drawing when you're behind. And then you want to drop based on cosine distance traveled rather than T distance traveled. That's where I was having trouble.
Well, okay. Can we start more basic than that? Like let's because you want to just like go at an angle, right? So why don't we just try to go? Should we try? Are you imagining they're gonna come out in an arc, or they're gonna come out as straight lines on the page?
Well, we're just dropping lights at this point, right?
Okay. So
we can just randomly drop some lights within the.
Should we try to just make this code like let's uncomment it. Right?
Sure. That's like an offset, I think. Well, I don't know.
Px is 0. Okay. For y, height of tree we have. That's a constant that we know. Height of tree. Y plus plus.
Well, so y is the t, right? Okay. So we could instead have a t variable.
I think y is. I mean, why don't we do dy? So you're going from dy to the height of the tree. It all makes sense.
Yep. Dy.
And you get some kind of like y step, right?
Mm-hmm. Yep.
Let's set y step as a constant. To unit, I don't know, divided by 4. Thanks. Okay. Well, let's just try to draw a strand of lights directly up the tree with no x dispersion at all. Just one at each y step, right? That's just a starting point.
Yep.
Okay. Lights equals just a list of offsets. Okay.
Mm-hmm.
Add offset. We don't know the x yet, but dy is our y. And our x is bottom of tree dot dx, right?
Sure.
Okay.
Yep.
And then we want to draw those points.
X though.
Okay.
Constant variables must be initialized with a constant value.
Okay, fine.
Is unit not const?
No, it has to do with the size of the canvas and such.
Oh, I see.
It's still it's performing
hot reload. Must be a hard one. Too much trigonometry.
How could it be hard? We're just drawing some lights.
Who knows what we did?
We've done something horrible.
I don't know what we could have done. Does this go forever? Yes. No.
Does it?
Well, is height of tree negative?
I don't know. No, height of tree is unit divided by 7. It's a positive number.
We made it sad.
We brokenated it.
I've never seen. Well, I'm sure I have seen, but I can't remember seeing Hoverload do that in a very long time.
Building the Windows application.
Yeah, the desktop world is still stuck in this where like these things take forever.
Just cleaning up the math here. Alan, thanks for joining us. I know this is a super weird time. We don't normally broadcast, but I'm glad you could make it.
Holiday tree. Whoa, why is it black?
This loop must be no good.
Let's try removing this.
Okay. It may be stuck in an infinite loop and unable to break out.
Huh. What did we do? Like, dy is less than height of tree. I mean, for one...
I mean, we should probably be iterating with integers instead of with floating points.
That was where I was going to start with. Is that double comparisons are never...
Yeah. Okay.
Rust screams at you.
Yeah. Let me work towards that. Let's see.
Those things.
Rows is height of tree divided by y step.
Sure.
And I need to turn this in integer somehow. Oh, it's like tilde divide.
Hey, we got a tree again. Yep.
We have to try this. Is then y step I times.
Mm-hmm.
Okay. There we go.
Yay!
Okay. So
I mean,
now we need some x component to what's going on here.
Well, we could start by math dot.
You probably want some kind of pi over 2 thing inside here,
right? Do you?
Well, I is like a number that goes to like 1 to 12, right?
Okay. You also need this to be based on the current radius.
Right. So why don't we try to compute the current? So we did the middle. Let's try to get a line that goes up like the left edge, right? So we should be able to figure out what that is. Left.
Well, you can just compute the slope of this line, right?
Mm-hmm. So this is like dy equals of tree dot plus your slope.
Oh, I see. I didn't understand what you were doing. Okay. So slope is going to be it's going to be y over x, right? So it's going to be final top of.
So you're doing y over x.
What tree? Why did that not work? What is
you have width and height, right? So there's like tree width and tree height. This height of tree. This is the height of the tree, and the width of the tree is. We didn't have a constant for it. I'll make a constant for the half width of tree. Half width of tree.
What went wrong?
Did it compile?
It compiled, yeah. All right, so slope is.
Let's put the 0 right here. Let's see what this is. Okay, that seems fine. So left. Let's try bottom of tree x.
You deleted your left.
Oh, we were adding in the bottom of the tree twice. What's happening? Okay. Minus. Okay. And then we need to add in something about the half width of the tree.
Okay. So
just throw the right constants.
What we actually want is radius equal to
the radius is just that first part, right? This is the radius.
Okay.
Okay. Tree radius.
At I or whatever at
y, sure. At y. Okay.
Okay. And so you want then
it's the other kind of pi. It's not the Python pi. You want some kind of angle step, right? Like the we didn't want a different loop here, which is like
I did something wrong. Okay.
This is fine. Let's just try this with like so because you want to put multiple things in each row, right?
Left at y is not used. What do you want?
Well, I'm trying to imagine what you want, right? So we have whatever it is, 10 or so rows, but you want to have more than one light per row to like go up, right?
Well, the weird thing that we're doing here is that in the real world, you're going based on distance traveled along the path. Whereas here, we're going based on some arbitrary, we're on our sampling points, right? Our arbitrary sample step.
Can I make a proposal?
Please.
So rather than invoking trigonometry, what if we try to draw like straight lines that go across zigzaggy?
Sure.
Right? So then like there's like the
you just alternate step points.
Yeah.
You pick you calculate your left and your right.
Oh, I want another loop here, which is like the number of lights per row, right?
Sure.
Like calls, right? Auto calls equals, let's just say 10. Okay, and I want for int j equals 0. Your notifications are going crazy there.
Yeah, I have no idea how to like make them stop either.
It's probably someone's like chatting with you or something.
Whatever. That's more for the checklist of next time.
Okay, so this cosine thing is not quite right here. So there's like the this is like bottom, right? And then top is this plus step over 2, right? Because you only want to go halfway to the next thing.
Mm-hmm.
Because the other half is on the back of the tree.
Okay.
Then you want to interpolate your actual y final dy is equal to whatever it is. Bottom plus top minus bottom. Oh, this is a lerp, right? Lerp. Can we give you we want a linear interpolate. I'm sure Flutter has all these really nice lerp functions.
Well, you could also just. Oh, I see. Because you're distributing the points. Okay, sure. Yep.
Lerp.
Yep, you can lerp.
Yeah, I'm just trying to figure out how do you do like a double lerp in Flutter.
Lerp double.
Lerp double? Oh, lerp double, perfect. So I want to lerp between bottom and top.
Mm-hmm.
And this is I divided by calls, A divided by calls. Right?
Okay.
X. This is my Y. And my X is going to be my radius at Y. So this is my T, right? Final T equals this. T is where I am on the lerp train. Times T times 2.
What's the 0.2?
Twice the radius. Something like that.
By undefined name dy.
That's legit. This is bottom.
Argument type question mark double.
Okay. All right.
I have no idea what it is, but it looks great. Ship it.
Okay. Something went wrong. Okay, let's just only try to do the X's.
I don't care. It looks amazing.
Oh, you know what? I misnested the parentheses.
2 positional arguments, but 1 found.
X. I didn't misnest the parentheses.
Can we pull that out? Because my poor little.
Let's just start with. Let's start with 0, just to start from someplace safe. Okay.
Int type cannot be assigned.
0.0.
Okay. We have a lot more lights than we think we do.
We have a lot more lights than we think we do. Okay.
And the frequency goes down, which I guess makes sense.
Why does that make sense? That doesn't seem right.
Well,
Oh, Y step times 0.5. This is bottom plus. Okay.
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 Oh, there was some sort of, when it does it again, there's a little, I think I can make him stop. I can put him in the penalty box. Okay. That looks really good.
But inverted.
Yeah, so your tree radius is, okay, here. Can we make it stop? Turn off, there
Turn
we
off
go.
notifications. We did it, team. Okay.
Only 28 notifications in.
Our tree radius at X, Y is our slope. So our slope should be negative. No. Our bottom needs to grow in the other direction.
Could you imagine doing this with a 2-minute compile step? Like, I was just thinking what you really need is like Mathematica or like a notebook. And then I was like, well, we kind of have that.
It's almost like, are you going up or down craziness? We're going up from the bottom, which I think is messing us up.
Well, this is still not right, though. Like,
No, it's fine. It's just the tree radius at x is wrong. That's the part that's wrong.
Well, but you don't
Because
want
if we set this to a constant, let's set this to a constant, right? Let's just say this is unit. Okay. Then that looks pretty good.
But no, but it's wrong. You want fewer lights at the top, which you had it doing that before.
Okay,
Also-
sure. So calls is a constant, so that's wrong. So right. Yeah, so this should really be our x step. It's also could be unit over, I don't know, 8. Unit over 2 is fine. Okay. And then our call should be, just like we did this, it should be width
A tree radius at
x and y divided by x step. Okay.
So this is probably because this is huge. Yeah, it needs to be like
Okay, change it.
this is wrong. Still, it should have been down to 1. Like, why is that a constant? Tree radius at y. Oh, because you made it equal to unit.
I made it equal to unit because our calculation for the tree radius is wrong. So let's just set it to half width of tree. Okay.
Okay.
So
This looks right.
Yeah, we just have to put it in the right place and trim it down. But we're getting close.
We are. So this is bottom of tree. We could center it. Why are we off by half a tree radius?
Okay, that's a good question. So that's an x problem, right? Our y's are fine. So our x is this. Oh, bottom of tree. Bottom tree is the bottom middle of the tree.
Yeah, that's bottom center.
Okay. So, I mean, we could just subtract half width of tree.
Mm-hmm.
So now, if our slope calculation was correct,
What'd you say?
now we need to work on our slope calculation.
Mm-hmm. And what happens if we?
So what if we just did height of tree minus bottom of that slope?
That's it. Tree radius at y is not centered around.
Look at this.
I mean, it's great.
It's good. No, it's good. It's just it's as if the tree was a right triangle instead of a equilateral triangle, right?
Okay,
Okay.
but our x's are wrong here.
Our x's are wrong. Yeah, our x's are still
They're
wrong.
not accounting for the slope.
They're not accounting for the tree radius at.
Oh, okay, sure. Oops. There you go. Really close.
Really close. Yeah. So there's some like rounding thing because we're just having a fixed step. Really, what we should do is we should put things exactly on the edge of the tree and then interpolate between them and absorb the integer fraction distance in the density.
Yeah. You can also just inset them a little bit. Although they do look better when they're on the edge. Exactly.
I'm going to put the star on top of the lights just for.
Yeah. Also, I don't think we want this to be draw points.
Because we want to give them different colors and stuff.
Yeah.
Yeah. But we're also at the hour mark. But
But I'm having fun, and it's holiday. I think we. I mean, unless you got someone to.
No, we can continue. Do you want to try to make them colorful, or do you want to try to clean up their placement a little bit? Which is more important to you?
I think the placement is probably more important. If we were trying to ship this, get this path to the designers, they would care more about our ugly ones out to the left. It also probably shouldn't start at 0, 0. It should start like.
Oh, you know what the other problem is? Like, look halfway up the tree. You see how that light is off outside of the tree? That's because, like that one, because we're taking the width of the tree at the bottom. We need to take the width of the tree at the next endpoint. So okay. I have another proposal for how to do this.
Sure.
Okay, we need to compute. We have the bottom and the top, right? We need the width at the top. Tree radius.
You need the width at both of them, honestly.
Yeah, at bottom.
Mhm.
Okay. And we need the tree radius at top. And then we just need to do interpolation.
Mhm.
Tree radius at top.
Mhm.
Okay. Then we have the number of calls, right? And then our T, and then we just need this lerping is what we should do. We need to lerp from bottom of tree dx minus tree radius at bottom to dx plus tree radius at top, right? I guess we can pull this out. Something like that. What does that do?
Undefined tree radius at y. This is now. This is now tree radius at that's bottom. Okay, and then dx undefined named y.
This
We
would
have
be T.
y. I'm going to type double question mark. What?
Oh, bang.
What it is.
4 bangs.
I think it didn't. I don't think it actually. Oh, does lerp double? Oh, interesting. It can return null. That did not work.
That did not work.
Maybe it did. Everything shifted. As you said, you want to peg the left-hand side and distribute.
Right. What if calls was always? What if we always did 2? Like we should be able to hit the edges of the trees, right? Right. That's the problem. So this is this famous. We want to hit 0, 0.0, and 1.0. Okay. And now we can increase this number.
What's up with Rudolph here?
Okay, so it was really good at 2, right? So let's go back to 2. We hit the edge and edge. What's wrong with 3? 3 should be right in the middle. Okay. 4. 5. 6. All these numbers look great. 7. So why?
Is it because they're all integers?
Maybe I didn't have integer divide.
You did not, but oh, that's remainder divide, I think.
Oh, what's integer divide?
Is it double? No.
This is right. It's something. It must have thrown an exception or gotten
Truncating
mad.
division operator. Yeah, you're right. It is.
Why did it?
Why does the?
It must be getting numbers that are. J.
Does it have output? Nope.
Because the star went away, right?
Oh. What's our exception?
T must be finite. Okay, so let's say math dot max of 2 and this thing. We have to have at least 2.
Okay.
This is looking good. So the density looks lower at the top. Maybe I always want to have at least 3. There you go.
Okay. You want these to curve a little more.
You want to put the curve in? Yeah, I totally agree.
Slope or like
Well,
occasionally.
that was when we do the lerp, we just need to apply a curve on the y.
Mm-hmm.
So curves dot ease in. Ease in.
In case you wondered if it was spam, by the way.
Yes. Curves that ease in. Transform internal? No. How do you transform?
I don't quite understand what you're doing. I remember all the curves. I remember that they exist. What is the ease in?
I'm making a permanent.
I thought you would just change the T.
Oh, yeah.
Right? Wouldn't you just lerp the T?
No, we want to curve the T.
Curve the T, but only on the Y direction.
Yeah.
But you don't want ease in. That is definitely doing a curve, not exactly.
Ease out? No.
It's not bad.
Ease out's the wrong way.
What are our curves?
Ease in out? Woo! We do this advanced trigonometry in the videos. Ease in. I think this is great, Eric. This is way better than I thought we were going to get.
Okay, for our last parting shot, what if we colored some of these?
Go for it.
All right. So
we can't use this draw points anymore.
We just got to draw them.
Yeah. So let's just take this, our whole paint thing up here, right?
Set up our paint. Something function.
This is going to be draw point, right?
Mm-hmm. Yep. And then we want colors. Those are the right colors, but. And what do we do? What are we drawing points here? We want to draw points.
Right. So you want colors, some index, right?
Sure. Mm-hmm. Paint's final.
Well, let's paint that color. Yay!
Not bad.
I think it's great. Merry Christmas.
Merry Christmas. Well, this was fantastic. I had fun. Thanks for joining us. Thanks for coming, Alan. And yeah, I guess we'll probably be on next week. Probably back at our normal Thursday time, unless that collides with the holiday. I can't. I haven't thought that far in advance.
Yeah, after the holidays, we'll be back to our regular Thursday schedule for sure.
So, any further words before we go back to our cookie eating / baking?
No, I think it's been a good year of shows, and maybe at some point we should do like a retrospective of like looking through the episodes and like thinking about which ones worked well and which ones didn't work well.
Thanks, Magnus.
Merry Christmas,
Merry
to you
Christmas to you too.
Oh, look, the Merry Christmas emoji somehow also looks maybe more like a Christmas tree than what we drew.
I think we could have taken some notes from the Merry Christmas emoji. Because another thing that we could have done was like the boughs off the side.
Oh, yeah.
Cool.
More and more trigonometry. It'd be amazing. All right, Eric. I'll see you next week. And
Yeah.
see you all.
Take care, everybody.